Greetings and hello, I'm Peter Denning, hosting your Harnessing AI lecture series. Today our topic is going to be AI and logistics. Logistics is an important, really important topic in the military. It has to do with, how do you get your supplies and necessary pieces of equipment to where they need to be. And this is a very complex problem over the years, and it's getting more and more complex now. It also flows over into the whole question of supply chains, because we're worried about how we supply ourselves and keep our equipment working, that's everything from computer equipment down to the actual battlefield equipment. So this logistics has been a very important problem, and now with AI coming on the scene, there's a lot of AI tools for helping to do the planning that's part of logistics. And today's speaker is Harrison Schramm, who works with the OR department and is a longtime statistician and working in operations research things. So he's going to talk to you about this topic and show you the complexity of the topic, but also that there are some really good ways to approach it with artificial intelligence. So,
okay,
Harrison.
Thank you, Peter, and thank you all for being here today. This is the first time that I've stood in front of a live studio audience, if you will, in almost 2 years. The last time I stood in front of a live audience at NPS, it was actually standing on this same lectern, if you will, talking about logistics in a different context. A couple things. It's a different world that we're in COVID. If this was a normal lecture, I would ask everyone to come and fill the front rows, but now please stay back, comfortably in the back as you are. And so, a couple things that are going to be scene setters before I get into the real meat and potatoes of our discussion today. And it is going to be a discussion. I'm going to go through these materials in about 30 minutes, and then hopefully we'll have a rich discussion about what I've said or what I haven't said afterwards. And these are that, to me, working at the intersection of computer science and statistics, our problems with AI are not technology problems. Given the will to do whatever we'd like to do, we have or can rapidly create the technology to do it. The problems that we're facing that you all need to be aware of, particularly as military officers or as audience members who are adjacent to the defense complex, the problems that we have are manpower and policy problems, really, in AI. That's the part that we haven't wrapped our heads around fully yet. So please keep that in mind as a backdrop as we get started. Okay, so today I'm going to talk about some things. I'm going to introduce myself. There's 3 things that are happening. And so I'm going to go through the 3 choose 2 equals 3 for the OR people. Are any OR people or stats people in the audience? Okay, so 3 choose 2 equals 3. The three different combinations of AI, supply chains, and great power competition. I'm going to go through a worked example. And I think the worked example that I'm going to show you today is not the worked example that you're expecting to see. And we can have some discussion about that, and then we'll get off the stage and end probably right about half past the hour and then begin our off-camera discussion. So by way of introduction, anybody know what this is? Ever fly one, ride on one? No, actually H-46 Sea Knight. These went out of service in about 2014-15 timeframe. I was at the Udvar-Hazy Center by Dulles Airport, where they brought the last one in for the last landing. That was my first fleet aircraft when I was on active duty. I'm a retired Navy commander. I spent, in the 20 years I spent in the Navy, almost to the month, half of it was spent in logistics helicopters. I flew H-46s in my first assignment, then I flew MH-60s off Guam, and then I was the OIC of the Desert Hawks out of Bahrain was my last operational assignment for anybody who's gotten mail when they were on a ship in 5th Fleet. And then the other half of my career was spent in operations research. I spent 2 years here as a student in the OR program. Then I spent a year at the Pentagon at N81, which is the Navy's OR shop. And then I went back to the fleet, and I came back, and I spent 3 years here as a military assistant professor and program officer in the OR department. And then I retired out of the headquarters Navy headquarters in the basement of the Pentagon, where a lot of the people that I worked with were my former students, which if you ever have that opportunity, it's wonderful. Particularly if they don't know something, they just have the ready excuse, well, you didn't teach me. And then currently, my day job, I'm a principal research scientist at Group W. We think about a lot of problems using high-end statistics, modeling and simulation, and we think about some logistics problems. I'm an intermittent lecturer, as Peter noted, here at the school. And of particular note, I'm the president-elect. I take over in October of the Analytics Society of Informs. So I'm going to be speaking from all of these different perspectives and weaving them through our exposition this afternoon. So what's AI and ML? It has been my professional experience that if you ask 5 people, you'll get 7 different answers. To the best of my knowledge, in the practice community, there is no universally accepted definition. That may be in conflict with what some of the previous speakers have said, and if they are, we can have a nerd fight about it later sometime. There is this concept of narrow AI versus broad AI. So broad AI is like Tony Stark's Jarvis, later turns into the Vision, and then had that spin-off television series. We're not there yet, and we're not going to be there for a long time. For some specific narrow applications, like we want to program a computer to do a thing that we used to think only humans could do, that is probably exists or is very close to on the horizon. Siri on your smartphones, for example. For the purposes of what I'm going to talk about today, large-scale inference, lots of data, computationally intensive. Dmitry Bertsimas, who's the Boeing chair at MIT, gave the Morse lecture at an Informs meeting a few years ago, and he pointed out that our ability to solve this class of problem has increased 1 billion-fold over the past 20 years. And while we don't like to declare things arbitrarily big or small, most people in the practice community think that 1 billion-fold improvement in ability is significant. And I already touched on this, but it solves problems that were previously considered to be the domain of humans. An example of this is the automatic telephone switchboard. During all of our lives, well, I think all of our lives, when you wanted to call somebody, you just dialed the number and it went through. There was not somebody in a back room plugging switchboards, but that used to exist in the 1950s. And if you went back to the 1950s and pulled out your smartphone and said, oh, hey, I just dialed the number and there's nobody that works there, it just goes through, they would think that this was some sort of magic from the future. So what we think of as AI today might not be what we think of as AI tomorrow. There is a real divide, and people my age, read almost old people, are on the cusp of it because people who grew up that are younger than myself, most of you in the audience, are what they call digital natives. You grew up with all this stuff. There was never a time that you didn't have a DVD player or a name something here. One of the things that's an example that we might talk about in the discussion afterwards is Spy 1A radar on an Aegis cruiser. That's not new technology. That's technology that's been around since the 1970s. Would you consider that AI or not? We'll table that until afterwards, but we will focus on how is this going to impact the future of logistics, how we do it, how we think about it, how it gets done. The cartoon here is actually important. Anybody here follow XKCD? Okay. XKCD is a webcomic about math. And so, you know, they say, this is your machine learning system. Yeah, you just pour all the data into this pile of linear algebra. Then you just stir, and when the answers start looking right, you declare it to be successful. The machine learning and the AI systems that people are building, to include machine learning systems that are built by myself, the practice is rapidly outstripping the theory. So we know that there are things that work. We know that certain approaches to building a neural network work better than others. We don't really have a theoretical foundation for why that is. We just know that it works. And so, yeah, to some extent, there's a lot more art going on in this than a lot of the other practitioners would like you to know. Okay. Our first of the 2x comparisons, logistics, supply chains, and AI and machine learning. These graphics, by the way, That looks like it could be from a military diagram. It's not. It's from the UN World Food Program. UN World Food Program has a logistics problem that I would say is 96% common with the military logistics problem. They have stuff, commodities. They have a smaller set of commodities because their commodities are mostly food and medicine. And they have a set of austere locations to get it to, mostly in Africa, but not all. And they have to figure out optimal routing for how to do this. The UN World Food Program were the winners of the Franz Edelman Prize this year through Informs. This is sort of like the Oscars for nerds. And they did it by applying techniques to their problem set, which quite frankly are very similar to those that are used in the military. So the big change, in my opinion, with AI is that we're going to make different decisions. We're going to make different kinds of decisions, not necessarily better, and that's one thing to keep in mind here. The future is going to blend what we know with what we can infer, or what we can predict, or what we can guess. All three of those things are equivalent, just depending on how much veracity you want to give to the claim. We'll be thinking about anticipated needs. We'll be thinking about anticipated disruptions. Question for the discussion period is, what happens if you get that wrong? And what are the penalties? When you go from certainty to inference, no matter how good your inference system is, there is an implicit assumption of risk. You're going to take on risk if you're going to start making inferences about what needs to be where and when. However, this is risk that you might need to take, and I'll get there in a couple slides. Second of our two-by comparisons is logistics, supply chains, and great power competition. COVID. COVID has been a watershed moment for supply chains all around the world, and not just military supply chains, for civil and industrial supply chains too. There's been shortages of, I'm sure you all know, paper towels and toilet paper and various paper goods. There's been shortages of wiring harnesses and certain bespoke semiconductors, which is why if you're looking to buy a new car, you have absolutely zero negotiating room right now. I know this, I bought a new car recently. In the prior era, prior to the day that we're standing in now, the sorts of ways that people think about this problem set focused on efficiency. And efficiency is a very attractive metric because I can measure absolutely what the cost of something is. I can measure what the cost of this policy is compared to this and this and this policy. And not only that, but I have really great mathematics that is really good at finding optimal solutions. We are not as good right now at finding fault-tolerant solutions. None of us are flying as much as we used to. In 2019, I took 30 work trips from Monterey to Washington, D.C. The bartender at the Dulles United Lounge knew my name. When you're at the Dulles United Lounge and the bartender knows your name, you're there way too much. But one of the things that you can experience in air travel is you can be sitting on the airplane, and I think some of you have probably experienced this, and you're sitting there and you're waiting, and you can't push back because one of the crew members is on another plane that was delayed. So efficient solutions can sometimes have fragility in the sense of cascading failure modes. So in the future, we need to be thinking about resilience versus efficiency. This is going to be an uphill battle for those of you who are going to end up serving on major staffs or at the Pentagon, because I don't have a great universally accepted way to define resilience. It's easy to compare the dollars. So that's going to be one of your challenges moving forward. AI, ML, and great power competition. This is the third of our two-by comparisons. So I had the privilege of sort of hanging out in the cheap seats and watching the National Security Commission on AI do their work via one of my friends who is a staffer for them. If you're interested in this, they've done a very nice job of turning their 500-page, some odd, report into a nice interactive web format. Lots of stuff about what the nation should do moving forward when it comes to AI and machine learning, and not the focus of today's lecture. But there are things that the United States will always do for the foreseeable future. One we will always have a man on the loop for combat systems at a minimum. There are certain types of information that we will not collect about our citizens. Other nations don't have those same restrictions. And so we need to understand, I don't think it's true that the US is at a disadvantage because of this. We have different nuances to our problem set as we move forward. Okay, this is the midpoint of the lecture, and I think I'm at about the midpoint on time. This has nothing to do with AI, but it's kind of a nice palate cleansing. This is the Painted Desert, which I stopped at on a drive back from visiting my family in the Midwest. It's interesting to see the richness and the texture of this created over millions and millions of years without the use of any sort of artificial intelligence or intelligence other than just the erosion of the Earth. The Earth will be here for a very long time. Okay, are we ready to get back into it? All right, here we go. So here's our worked example. As I was trying to come up with doing this, I didn't want to just have blobs on a map, but then I didn't want to have blobs on a map that was of some place because I didn't want to inadvertently stumble across something that people were thinking about in the past, present, or future. So this is Middle Earth. For those of you who are Tolkien fans, if you're going to accuse me of being some kind of nerd, you're way past being in the wrong room for that. So you can see that if you're going to start at the Shire and you're going to end up at Mount Doom, it's going to take you 6 months. And you have to have caution because the route has trolls. So this is going to be the backdrop to a very simple, the minimum scenario I could come up with that was simple without being simplistic. To just think about this. And so here's our laydown. I've got logistics ship here in orange. I've got a naval group to the north in blue. I've got a naval group to the south in blue. I've got some forces ashore here in green. And I've got opposition force on either ends of Barad-dûr. So just pause for a second and think, okay, if you were a logistician, if you know what you know about how the fleet operates today, how do you think you would plan this? And you would probably come up with something that looks like this. So these dashed lines are requests that are going to this gigantic eye in the sky, this sort of controller, if you will, that's going to create an overarching logistics plan. And then that eye in the sky is going to download all that information to the logistics group there in yellow, and they're going to do something that's going to look like this. So the logistics force is going to go north. It's going to offload supplies to those ships. What do those ships need? Well, they got a requisition. They know what they need because they were told. They're going to go down here. Maybe they'll come closer. They're going to fly via helicopter or small boats or whatever. They're going to shift forces ashore to the green supplies ashore to the green forces. Then they're going to come down to their final position here outside the southern group. And the OPFOR, I don't know what they're doing. So that's one way to think about that. Now, let's think about all of the assumptions that are baked into this plan, because there's a lot. In fact, some of them are so basic, we've actually forgotten that they're assumptions. So everybody got serviced, right? The logistics plan, if you were in operations research, you would say the optimization problem was feasible. Everybody got what they needed. Prioritization was based on need. That's mostly self-reported need. I wasn't really concerned about the risk to those yellow ships. I figured they were going to get where they needed to go. It is efficient. The supply ships burned the minimum amount of fuel and took the minimum amount of time to get the supplies to where they go. There was this idea of centralized control. So if you're going to assume there's centralized control, then you're going to assume functionally unlimited communications. By functionally unlimited, I mean, no, you cannot push your 20 gigabyte PowerPoint from ship to ship, but functionally in the sense that you can send messages that would be useful and necessary. And it also kind of assumes maritime and air supremacy. So what's wrong with all that? So let me get to my next slide. So what's wrong with it is that it doesn't take any risk because it doesn't think that it has to. So future scenarios are going to include no longer having functionally unconstrained communications, no longer having what my friend and colleague, the great Wayne Hughes, who passed a few years ago, used to like to call the sanctuary of the sea. You might not be able to fully service all your customers. So the decision to service or not to service is a risk decision. My one foot stomper for this whole lecture, if you remember nothing else from having met me here today on Monday afternoon, if you're working scenarios in the future and your scenario doesn't ever touch upon cases where the logistics problem is infeasible, where you are actually forcing yourself to choose who gets serviced and who doesn't get serviced, then your scenario probably isn't hard enough. Oh, the chess piece. This isn't a random chess piece. This is the pawn, the king's gambit, opening from chess. Pawn moves here, offers itself as a sacrifice to black's pawn. If black's pawn takes the sacrifice, then the material advantage given to black is overcome by the weakness introduced into the underlying structure of the pawns by white. White has traded material for tempo and position. So this is about AI, and you're probably scratching your head saying, gosh, is Harrison going to talk about AI? So let's talk about this, and let's talk about this with an AI-enabled logistics scenario that doesn't depend on a controller in the sky. So I've got the same identical laydown. I know it's identical because I copied and pasted the slides. Thank you, PowerPoint. Now, here's some arrows that weren't on the other slide. The logistics force here gathers the information that it can gather, and it makes inference about the future plan. It infers that these ships are going to move this way. It infers that those guys are going to move that way. It infers that the OPFOR is not just going to sit there, and that their southern group is going to mount a massive attack on the southern blue ships. So it comes up with a plan that looks like this. Starting here, moves to the first position, catches the blue ships as they are in transit southward. Closest point of approach, however, factors for the notion that these guys have moved before they have moved, and that wasn't explicitly communicated, that was inferred, it was guessed. And then they come here and finish at point number 2, and unfortunately the logistics assets make the risk decision that the southern group resupplying them is infeasible. They're going to be out of all their munitions by the time you got there, and they were, in a sense, sacrificed. So this is one possibility of what AI-enabled future logistics in great power competition might look like. So when we think about the AI, and we think about the decision support tools that were used in this, we think, okay, what did this thing really decide? Because on the surface, well, it was deciding, who got what groceries and who got what beans, bullets, and bandages. But at a higher level, it's deciding something other than that. It's independently second-guessing what the commander's plan was. It's also independently second-guessing what Red's plan is. It's making a decision as to what was feasible to supply and what isn't feasible to supply. It's, in a sense, and then it's deciding who gets what munitions. Particularly, I believe they're still called preferred munitions. Ultimately, this supply chain is deciding who lives and who dies. And I've got because of the popularity of the Marvel movies, it's very hard to find a picture of a Valkyrie that's not, from the Thor movies. So anyway, we seem to have come a good deal further than we thought we were going to go when we sat down to have this discussion 26 minutes ago. Okay, I've got a couple other things to talk about, and then we'll go into Q&A. So this is beyond the topic of AI and supply chains, but I would be professionally irresponsible if I didn't touch on a couple of these things. There's a tension between natural intelligence and machine intelligence. Your senior non-commissioned officers, when you're back in the field, they know things about the people that you serve with. They have very complicated, very nuanced neural networks inside their brains. You can't download them to a USB stick, but they have something called natural intelligence. Artificial intelligence or machine intelligence, here's a problem that machine intelligence is really good at. On a Friday night, if I'm shopping Amazon, I'm drinking a beer and I'm wearing my fuzzy bunny slippers, it knows what to show me. It knows what to show me because it sees lots and lots of people drinking beer wearing fuzzy bunny slippers. That's part one. Part two is that there's no real penalty in a real sense for the Amazon algorithm to show me an ad for something that I don't want. I mean, they have a penalty function in the way they do their algorithms, but it's not realized. So humans are, and for the foreseeable future will remain, the best at scenarios where the data either is uncertain or does not exist, and the rules change on the fly. So the real call in our age is to balance natural intelligence with machine intelligence. Give machines tasks that they are good at. Give humans tasks that humans should do. There's a lot of societal implications. There's a lot of homework here for lawyers and professional ethicists. I think I've cut a big enough piece of homework for them in the last couple minutes, so I don't need to go about that anymore. These last two were former Deputy Secretary of Defense Robert Work's signature touches on the NSCAI report. It's talking about immigration and education, and then the talent distribution within the United States. Every person that I know who is a statistician or in operations research is as employed as they want to be. Some of us have been more employed than we wanted to be because we had clients that we just didn't want to say no to. The demand for these skill sets, both inside and outside the public sector, are fierce, and the talent competition, which is something you don't think about very much when you're on active duty unless you're in recruiting, but the talent competition is fierce. And it's going to remain that way for the foreseeable future because we are simply not producing enough graduates with these skills to fill all of our jobs. And then the final thing that I have here is talent distribution. This also touches on one of Mr. Work's recommendations to create a National Digital Service Academy. I believe that the talent for doing this type of work is evenly distributed, but the opportunity is not. And that's also a policy challenge that we have to address, but outside the scope of logistics. This is my almost get off the stage slide. I'm going to recommend two things to you. New book by the Naval Institute called AI at War. Full disclosure, I'm one of the authors of one of the chapters. However, I signed all my royalties back over to the Naval Institute. So if you buy the book, it's not like I get any money out of it. It's reasonably priced. I think it's $25, and I'm pretty sure the Dudley Knox Library has it either physically or digitally. The other one is a piece that I wrote with my friend and colleague Jeff Klein in operations research a couple of years ago for War on the Rocks, asking the provocative question as far as our thoughts as a service and nationally about AI. Are we educating AI's masters or are we training its servants? If you'd like to read some more disturbing thoughts on that, you can download that article. It's for free in War on the Rocks. Just type my name in and a couple things will pop up. Okay, this is my final slide, and I'm ready, hopeful to have interesting questions and hopefully maybe have an argument or two. That's my story.